the question why material selection is so important in RF designs is that the base material is not just the carrier for your transmission lines. It's much, much more. It's influencing your signals. It's influencing the transmission parameters like propagation speed. It causes a phase shift. It causes losses, attenuation. The metal cladding is also affecting the losses, and we are going into that a little bit deeper in follow-up slides. But you can't just think of a metal as a flat surface. There are roughnesses involved. There is a shape of a trace involved. All of that matters. And particularly in RF, we very often have structures that are passive elements like inductances, coils, or capacitance, and you can form filter circuits with that. So it's not just a pure transmission from A to B. It's much, much more. And again, tolerances of all the parameters, dielectric thickness, decay, DF, line width, and so on. Tolerances are key. The name of the game is as few tolerances as possible. Now, having spoken about that there are HSD and RF requirements, you will see that there are also materials that are tailored for HSD and materials that are tailored for RF. And the question very often is, what's the difference? And what we on our end do is in RF that we have constructions that keep a certain decay for all offered thicknesses. On the HSD side, that's different. Typically, resin content changes over thickness, which affects decay. You don't want to have that in RF microwave, so we make sure that independent of thickness, you get the same decay. There's no change of resin content. There's the reduced thickness tolerances. Again, we don't want to have too much tolerances at all. We want to reduce variation. That's why we have to do that. And then there's testing of electrical properties of dielectric constant and dissipation factor for every batch, which in turn makes the materials very stable and repeatable.